Hi guys, today I am discussing about the subject probability theory and static process. This is presented by GVS Amarendra Reddy with registered roll number 24BQ1A0436. In this subject, I am took the one of the topic about power density spectrum and its properties, and the another one is cross power density spectrum and its properties. Power density spectrum. Definition of power density spectrum. Power density spectrum of a WSS random process x of t is defined as the Fourier transform of autocorrelation function Rxx of tau. It is given by xx of omega is equal to integral minus infinity to Rxx of tau e power minus j omega tau d tau. The inverse relationship is also true. The autocorrelation function can be obtained from the Ptsp using the inverse Fourier transform. Rxx of tau is equal to 1 by 2 pi integral minus infinity to infinity xx of omega e power minus omega my sorry Rxx of tau is equal to 1 by 2 pi integral minus infinity to infinity xx of omega e power j omega tau d tau. Thus the power spectral density and the autocorrelation function are the Fourier transform pairs. Note, if x of t is a capital X of t is a real process, then the both Rxx of tau and xx of omega are the real and even functions. This means Rxx of tau is equal to Rxx of minus tau, xx of omega is equal to xx of minus omega. Definition of alternative form of PhD. The power spectral density can be defined as xx of omega is equal to limit t tends to infinity expectation of xt omega square by 2t. Here xt of omega is the Fourier transform of the truncated random process of x of t over the time interval minus t to t. Now we are moving to the power density spectrum of its properties. Property 1, xx of omega greater than or equal to 0. Proof. From the definition, the expectation value of the non-negative function expectation of xt of omega whole square is always non-negative. Hence, xx of omega greater than or equal to 0. Now we are moving to the property 2. The, the power spectral density at 0 frequency is equal to the area under the curve of the autocorrelation Rxx of tau. That is, xx of 0 is equal to integral minus infinity to infinity Rxx of tau d tau. Proof. From the definition, we know that xx of omega is equal to integral minus infinity to infinity Rxx of tau e power minus j omega tau d tau. Yet omega is equal to 0. Xx of omega is equal to integral minus infinity to infinity Rxx of tau d tau. Property 3. The power density spectrum is a real process of x of t is even function, that is xx of minus omega is equal to xx of omega when x of t is real. Proof. Consider a wide sense stationary real process x of t. Xx of omega is equal to minus infinity to infinity Rxx of tau e power minus omega tau d tau. Also, xx of minus omega is equal to integral minus infinity to infinity Rxx of tau e power j omega tau d tau. Substitute tau is equal to minus tau. Then L dash of xx of minus omega is equal to integral minus infinity to infinity Rxx of tau e power minus j omega tau d tau. Since x of t is a real, from the properties of autocorrelation, Rxx of minus tau is equal to Rxx of tau. Therefore, xx of minus omega is equal to integral minus infinity to infinity rxx of tau e power minus j omega tau d tau. Therefore, xx of minus omega is equal to xx of omega. Here the property 4. Xx of omega is always a real function. Proof. Xx of omega is equal to limit t tends to infinity expectation of xt of omega whole square by 2t. Since the function x of xt of omega whole square is a real function. Sorry, this is mod xx of omega is always real. Now, the another topic is cross power density spectrum. Definition. Consider a two random process x of t and y of t. If x of t and y of t are jointly wide sense stationary random process, then the cross power density spectrum is defined as Fourier transform of cross correlation function of x of t and y of t. It is expressed as s x y omega is equal to integral minus infinity to infinity r x y tau e power minus j omega tau d tau, and x y x omega is equal to integral minus infinity to infinity r y x tau e power minus j omega tau d tau. By inversing Fourier transform, we can obtain the cross correlation functions, that is rxy tau is equal to 1 by 2 pi integral minus infinity to infinity xxy omega e power minus j omega tau d tau, and the another function another formula is ryx tau is equal to 1 by 2 pi integral minus infinity to infinity s yx omega e power j omega tau d d omega tau d omega. Therefore, the cross power density function, spectral density, and cross correlation function are Fourier transform pairs. Definition. The another definition of cross power density function. If xt of omega and yt of omega are Fourier transforms of x of t and y of t respectively in the interval minus t to t, then the cross power density function spectrum is defined as sxy omega limit is equal to limit t tends to infinity expectation of x star of t omega y yt of omega by 2t, and another formula is x s yx omega is equal to limit t tends to infinity expectation of y star y yt star omega xt of omega by 2t. Properties of cross power density spectrum. First property, Sxy omega is equal to Syx of minus omega. Proof. Consider a cross correlation function Rxy of tau. The cross power density spectrum is given by Sxy of omega integral minus infinity to infinity Ryx of tau e power minus j omega tau d tau. Let tau is equal to minus tau. Then Sxy of omega is equal to minus infinity to infinity Rxy of minus tau into e power minus j omega tau d tau. Since Rxy minus tau is equal to Ryx of tau, Sxy of omega is equal to integral minus infinity to infinity Rxy of tau e power minus j into minus omega tau d tau. Then xy of omega is equal to syx of minus omega. The property 2. The real part of xxy of omega and the real part of xy of omega are the even functions of omega, that is real of re, that is real sxy of omega and real syx of omega is even functions. Proof. Consider a xy of omega is equal to integral minus infinity to infinity rxy of tau e power minus j omega tau d tau. Since we know e power minus j omega t is equal to cos omega tau minus j sin omega tau, real function of sxy of omega is equal to integral minus infinity to infinity rxy of tau cos omega tau d tau. Since cos omega tau is an even function, that is cos omega tau is equal to cos minus tau, real function of sxy of omega is equal to integral minus infinity to infinity rxy of tau cos omega tau d tau, that is equal to integral minus infinity to infinity rxy of tau cos minus omega tau d tau, real function of sxy of omega is equal to real function of sxy of minus omega. Hence, real function of xy omega is an even function. Similarly, real function of yx of omega is also an even function. In last property, we have seen the real part. Now in this property, we have seen the imaginary part of s xy of omega, and the imaginary part of s yx of omega are odd function of omega. That is, imaginary of s xy of omega and imaginary of s yx of omega are odd functions. Proof: consider a syx of omega is equal to integral minus infinity to infinity rxy of tau e power minus j omega tau d tau, and sxy of omega is equal to integral minus infinity to infinity rxy of tau into cos omega tau minus j sin omega tau d tau. Imaginary of sxy of omega is equal to integral minus infinity to infinity rxy of tau into minus sin omega tau d tau, that is equal to integral minus infinity to infinity rxy of tau sin omega tau d tau. Now imaginary of sxy of minus omega is equal to minus integral minus infinity to infinity rxy of tau sin sin of minus omega tau d tau, that is equal to minus integral minus infinity to infinity rxy of tau into minus sin and omega tau d tau, that is equal to integral minus infinity to infinity rxy of tau sin omega tau d tau. Hence imaginary of xy of minus omega is equal to minus imaginary of sxy of omega. Imaginary of xy of omega is an odd function of omega. Similarly, imaginary of xy of omega is also an odd function. Now the property for x s xy of omega is equal to 0 and s yx of omega is equal to 0 if x of t and y of t are orthogonal. Here the proof. From the properties of cross correlation function, we know that the random process of x of t and y of t is said to be a orthogonal if and only if there are cross correlation function is 0, that is rxy of tau is equal to ryx of tau is equal to 0. We know that sxy of omega is equal to integral minus infinity to infinity rxy of tau e power minus j omega tau d tau. Therefore, sxy of omega is equal to 0 and x and also s yx of omega is equal to 0. Thank you.